Hi everyone, this is Glenda Ganzon and welcome to my Human Anatomy and Physiology class. And for today's lesson, I'm going to discuss the vertebral column in the human skeletal system. So stay tuned. The vertebral column is also known as the spinal column or spine. It consists of a sequence of vertebrae, each of which is separated and united by an intervertebral disc. Together, the vertebrae and the intervertebral disc form a vertebral column. It is a flexible column that supports the head, neck, and body and allows further movements. It also protects the spinal cord, which passes down the back through the openings in the vertebrae. The vertebral column originally develops as a series of 33 vertebrae, but this number is eventually reduced to 24 vertebrae plus the sacrum and coccyx. The vertebral column is subdivided into 5 regions, with the vertebrae in each area named for that region and numbered in descending order. In the neck, there are 7 cervical vertebrae, each designated with the letter C, followed by its number. Superiorly, the C1 vertebra articulates, forms a joint with the occipital condyles of the skull. Inferiorly, C1 articulates with the C2 vertebra, and so on. Below this are the 12 thoracic vertebrae designated as T1 to T12. The lower back contains the L1 to L5 lumbar vertebrae. The single sacrum, which is also part of the pelvis, is formed by the fusion of 5 sacral vertebrae. Similarly, the coccyx or tailbone results from the fusion of 4 small coccygeal vertebrae. However, the sacral and the coccygeal fusions do not start until age 20 and are not completed until middle age. An interesting anatomical fact is that almost all mammals have 7 cervical vertebrae regardless of the body size. This means that there are large variations in the size of cervical vertebrae, ranging from the very small cervical vertebrae of a shrew to the greatly elongated vertebrae in the neck of a giraffe. And in a full-grown giraffe, each cervical vertebrae is 11 inches tall. The adult vertebral column does not form a straight line, but instead, it has 4 curvatures along its length. And these curvatures increase the vertebral column's strength, flexibility, and ability to absorb shock. So when the load on the spine is increased by carrying a heavy backpack, for example, the curvatures increase in depth and it becomes more curved to accommodate the extra weight. They then spring back when the weight is removed. The 4 adult curvatures are classified as either primary or secondary curvatures. Primary curves are retained from original fetal curvature, while secondary curvature develop after birth. So during fetal development, the body is flexed anteriorly into the fetal position, giving the entire vertebral column a single curvature that is concave anteriorly. So in the adult, this fetal curvature is retained in 2 regions of the vertebral column as the thoracic curve, which involves the thoracic vertebrae, and the sacrococcygeal curve formed by the sacrum and coccyx. So each of these is thus called a primary curve because they are retained from the original fetal curvature or fetal curvature of the vertebral column. A secondary curve develops gradually after birth as child learns to sit upright, stand, and walk. Secondary curves are concave posteriorly, opposite in direction to the original fetal curvature, and the cervical curve of the neck region develops as the infant begins to hold their head upright when sitting. Later, as the child begins to stand and then to walk, the lumbar curve of the lower back develops, In adults, the lumbar curve is generally deeper in females. Disorder associated with the curvature of the spine include kyphosis, an excessive posterior curvature of the thoracic region. Also, lordosis is an excessive anterior curvature of the lumbar region. And the last one is scoliosis, which is an abnormal lateral curvature accompanied by twisting of the vertebral column. Within the different regions of the vertebral column, vertebrae vary in size and shape, but they all follow a similar structural pattern. A typical vertebra will consist of body, a vertebral arc, and 7 processes. So the body is the anterior portion of each vertebra and is the part that supports the body weight. Because of this, the vertebral bodies progressively increase in the size and thickness going down the vertebral column. The bodies of adjacent vertebrae are separated and strongly united by an intervertebral disc. The vertebral arc forms the posterior portion of each vertebra. It also consists of 4 parts, the right and left pedicles and the right and left laminae. Each pedicle forms one of the lateral side of vertebral arc. The pedicles are anchored to the posterior side of the vertebral body, and each lamina forms part of the posterior roof of the vertebral arc. The large opening between the vertebral arc and body is the vertebral foramen, which contains the spinal cord. In the intact vertebral column, the vertebral foramina of all the vertebrae align to form the vertebral canal, which serves as the bony protection and passageway for the spinal cord down the back. So when the vertebrae are aligned together in the vertebral column, not just in the margins of the pedicles of adjacent vertebrae, together form an invertebral foramen, the opening through which a spinal nerve exits from the vertebral column. 7 processes arise from the vertebral arc. Each paired transverse process projects laterally and arises from the junction point between the pedicle and lamina. The single spinous process or vertebral spine projects posteriorly at the midline of the back. The vertebral spines can easily be felt as a series of bumps just under the skin down the middle of the back. The transverse and spinous processes serve as important muscle attachment sites. So a superior articular process extends or faces upward, and an inferior articular process faces or projects downward on each side of a vertebrae. And the paired superior articular processes of one vertebra join with the corresponding paired inferior articular processes from the next higher vertebra. And these junctions form slightly movable joints between the adjacent vertebrae, and the shape and orientation of the articular processes vary in different regions of the vertebral column and play a major role in determining the type and range of motion available in each region. In addition to the general characteristics of a typical vertebra, vertebrae also display characteristic size and structural features that vary between the different vertebral column regions. Thus, cervical vertebrae are smaller than lumbar vertebrae due to the differences in the proportion of the body weight that each supports. Thoracic vertebrae have sites for rib attachment, and the vertebrae that give rise to the sacrum and coccyx have fused together into single bones. The typical cervical vertebrae, such as the C4 or C5, have several characteristic features that differentiate them from thoracic or lumbar vertebrae. So cervical vertebrae have a small body, reflecting the fact that they carry the least amount of body weight, and cervical vertebrae usually have a bifid, that is Y-shaped spinous process. So the spinous or spinous processes of the C3 to C6 vertebrae are short, but the spine of C7 is much longer. So you can find this vertebrae by running your finger down the middle of the posterior neck until you encounter the prominent C7 spine located at the base of the neck. And the transverse processes of the cervical vertebrae are sharply curved or U-shaped to allow the passage of the cervical spinal nerves. And each transverse process also has an opening called the transverse foramen. An important artery that supplies the brain ascends up the neck by passing through these openings. So the superior and inferior articular processes of the cervical vertebrae are flattened and largely face upward or downward respectively. And first and second cervical vertebrae are further modified, giving each a distinctive appearance. So the first cervical or C1 vertebra is also called as atlas, because this is the vertebra that supports the skull on top of the vertebral column. So Atlas was the god who supported the heavens in his shoulders. And the C1 vertebra does not have a body or spinous process. Instead, it is ring-shaped, consisting of an anterior arc and posterior arc. The transverse process of the atlas are longer and extend more laterally than the transverse process of any other cervical vertebrae. The superior articular processes face upward and are deeply curved for articulation with the occipital condyles on this base of the skull. And the inferior articular processes are flat and face downward to join with the superior articular processes of the C2 vertebra. The second cervical or C2 vertebra is called the axis because it serves as the axis for rotation when turning the head toward the right or left, and the axis resembles typical cervical vertebra in most respects but easily distinguished by the dens or odontoid process, which is a bony projection that extends upward from the vertebral body, and the dens also joins with the inner aspect of the anterior arc of the atlas, where it is held in the place by transverse ligament. On the other hand, the bodies of the thoracic vertebrae are larger than those of cervical vertebrae. The characteristic feature of a typical mid-thoracic vertebra is the spinous process, which is long and has a pronounced downward angle that causes it to overlap the next inferior vertebra. So the superior articular processes of the thoracic vertebra face anteriorly and the inferior processes face posteriorly. And these orientations are important determinants for the type and range of movements available to the thoracic region of the vertebral column. In addition, thoracic vertebrae have several additional articulation sites, and each of which is called a facet, where a rib is attached, and most thoracic vertebrae have two facet located in the lateral side of the body, and each of which is called a costal facet. These are for articulation with the head of the rib, and an addition facet is located on the transverse process for articulation with the tubercle of a rib. On the other hand, lumbar vertebrae carry the greatest amount of body weight and are thus characterized by the large size and thickness of the vertebral body. So they have short transverse processes and a short blunt spinous process that projects posteriorly, and the articular processes are large with the superior process facing backward and the inferior facing forward. The sacrum is a triangular shaped bone that is thick and wide across the superior base, where it is weight-bearing and then tapers down to an inferior, non-weight-bearing apex. It is formed by the fusion of 5 sacral vertebrae, a process that does not begin until after the age of 20. On the anterior surface of the older adult sacrum, the lines of vertebral fusion can be seen as 4 transverse ridges. On the posterior surface, running down the midline is the median sacral crest, a bumpy ridge that is the remnant of the fused spinous process, but not necessarily at the midline. So similarly, the fused transverse process of the sacral vertebrae form the lateral sacral crest. The sacral promontory is the anterior lip of the superior base of the sacrum. Lateral to this is the roughened articular surface, which joins with the ilium portion of the hip bone to form the immobile sacroiliac joints of the pelvis. Passing inferiorly through the sacrum is the bony tunnel called the sacral canal, which terminates the sacral hiatus near the inferior tip of the sacrum. So the anterior and posterior surfaces of the sacrum have a series of paired openings called sacral foramina that connect to the sacral canal, and each of these openings is called a posterior or dorsal sacral foramen or anterior or ventral sacral foramen. These openings allow for the anterior and posterior branches of the sacral spinal nerves to exit the sacrum. And the superior articular process of the sacrum, one of which is found on either side of the superior opening of the sacral canal, articulates with the inferior articular processes from L5 vertebra. The coccyx or tailbone is derived from the fusion of the 4 very small coccygeal vertebrae, and it articulates with the inferior tip of the sacrum, and it is not weight-bearing in the standing position but may receive some body weight when sitting. The bodies of adjacent vertebrae are strongly anchored to each other by an intervertebral disc. This structure provides padding between the bones during weight bearing, and because it can change shape, also allows for movement between the vertebrae. Although the total amount of movement available between any 2 adjacent vertebrae is small, when these movements are summed together along the entire length of the vertebral column, large body movements can be produced. Ligaments that extend along the length of the vertebral column also contribute to its overall support and stability. An intervertebral disc is a fibrocartilaginous pad that fills the gap between adjacent vertebral bodies. Each disc is anchored to the bodies of its adjacent vertebrae, thus strongly uniting this. The discs also provide padding between vertebrae during the weight bearing. Because of this, intervertebral discs are thin in the cervical region and thickest in the lumbar region, which carries the most body weight. In total, the intervertebral discs account for approximately 25% of your body height between top of the pelvis and the base of the skull. And intervertebral discs are also flexible and can change shape to allow for movements of the vertebral column. Each intervertebral disc consists of 2 parts. The annulus fibrosus is the tough, fibrous outer layer of the disc. It forms a circle and is firmly anchored to the outer margins of the adjacent vertebral bodies. And inside is the nucleus pulposus, consisting of a softer, more jelly-like material. It has also a high water content that serves to resist compression, and thus it is important for weight bearing. With increasing age, the water content of the nucleus pulposus gradually declines. This causes the disc to become thinner, decreasing total body height somewhat, and reduces the flexibility and range of motion of the disc, making bending more difficult. The gel-like nature of the nucleus pulposus allows the intervertebral disc to change shape as one vertebra rocks side to side or forward and back in relation to its neighbors during movements of the vertebral column. And thus, bending forward causes compression of the anterior portion of the disc, but expansion of the posterior disc. And if the posterior annulus fibrosus is weakened due to injury or increasing age, the pressure exerted on the disc when bending forward or lifting a heavy object can cause the nucleus pulposus to protrude posteriorly through the annulus fibrosus, resulting in a herniated disc. The posterior bulging of the nucleus pulposus can cause compression of the spinal nerve at the point where it exists through the intervertebral foramen, when resulting pain and or muscle weakness in those body regions supplied by that nerve. The most common sites for this herniation are the L4, L5 or L5 and S1 intervertebral disc, which can cause sciatica, which is a widespread pain that radiates from the lower back down high and into the leg. Similar injuries of the C5, C6, or C6, C7 invertebral disc following forcible hyperflexion of the neck from a collision accident or football injury, and can produce pain in the neck, shoulder, and upper limb. Adjacent vertebrae are united by ligaments that run the length of the vertebral column along both its posterior and anterior aspects. These serve to resist excess forward or backward bending movements of the vertebral column respectively. So the anterior longitudinal ligament runs down the anterior side of the entire vertebral column, uniting the vertebral bodies. It serves also to resist excess backward bending of the vertebral column. Protection against this movement is particularly important in the neck, where extreme posterior bending of the head and neck can stretch or tear this ligament, resulting in a painful whiplash injury. And prior to the mandatory installation of seat headrest, or whiplash injuries were common for the passengers involved in rear-end automobile collision. The supraspinous ligament is located on the posterior side of the vertebral column, where it interconnects the spinous process of the thoracic and lumbar vertebrae. And this strong ligament supports the vertebral column during forward bending motions. In the posterior neck, where the cervical spinous process are short, the supraspinous ligament expands to become the nuchal ligament. The nuchal ligament is attached to the cervical spinous or spinous processes that extends upward and posteriorly to attach to the midline base of the skull out to the external occipital protuberance. It also supports the skull and prevents it from falling forward. And this ligament is much larger and stronger in four-legged animals such as cows, where the large skull hangs off the front end of the vertebral column. You can easily feel the ligament by first extending your head backward and pressing down on the posterior midline of your neck. Then tilt your head forward and you will feel the nuchal ligament popping out as it tightens to the limit anterior bending of your head and neck. Additional ligaments are located inside the vertebral canal. next to the spinal cord along the length of the vertebral column. The posterior longitudinal ligament is found anterior to the spinal cord, where it is attached to the posterior sides of the vertebral bodies. Posterior to the spinal cord is the ligament flavum. This consists of a series of short, paired ligaments, and each of which interconnects the lamina regions of adjacent vertebrae. And the ligamentum flavum has large number of elastic fibers which have a yellowish color, allowing it to stretch and then pull back. Both of these ligaments provide important support for the vertebral column when bending forward. So this ends my lecture about the vertebral column of the skeletal system. And if you have any question, please write it in the comment section down below, and I'll be glad to answer them all. And if you're still not subscribed to my channel, please do consider subscribing. Also hit the notification button so that you'll be updated with my new videos. And also, if you like this video, please like and share. So I would like to thank you all for watching this video and for listening to my discussion. Until my next video, bye everyone!